Today we're going to learn about simplifying radical expressions. It's very simple, very similar to simplifying fractions, but we also have exponents and variables that go along with that. You've learned how to do everything you're going to do. It's just a matter of putting it all together. Okay, let's quickly go through this lesson opener. We have three rational expressions here. Two look like simple fractions that you're used to simplifying. The other one has letters and variables. You also know how to simplify these though, because you know how to divide with like bases with exponents. So let's look at this first one. When we reduce it, it turns into 1 over 6. The second one is 13 over 11. And this third one turns into x to the 6th power over y. The reason the y ends up on the bottom and the x ends up on the top is because when you go 1 minus 2, you end up with -1. That makes it have to be on the bottom of your fraction. When you go x minus 2, you end up with +6, and the positive exponents go on the top. So remember, positive exponents always go on the top of the expression, and negative exponents always go on the bottom of the expression. Okay, so let's look at these. They're a little more complex. First of all, we have 6 over 3, which reduces down to 2 over 1. And then we have x to the 6th and x to the 3rd, which is going to reduce to be x to the 3rd because you take 6 minus 3. Now let's look at this next one. You just simply reduce the numbers and then go letter by letter and reduce as necessary. Notice there are no exponents for the b's, so they just cancel each other out. It's the same as 1. b over b or 2 over 2 or any of that is the same as 1, so it just goes away. So let's remind ourselves of what a rational number is. It's a rational number that can be expressed as a numerator and a denominator, and any of our properties to any rational numbers can also be related to rational expressions. A rational expression is polynomials or some type of groups of numbers and letters that have a numerator and a denominator. That denominator could just be 1, but the denominator cannot be 0. A fraction with the denominator of 0 is an undefined fraction. So whenever we look at rational expressions, we're going to look at an excluded value. That's the value of x, or whatever the variable is, that would cause the denominator to be 0. That means our variable cannot be that number. So this is a rational expression because we have a number over a number. And if we think about the denominator, let's specifically focus on the denominator. What could x be that would cause the denominator to be 0? It's -2. -2 plus 2 equals 0. So an excluded value for x is -2. X cannot equal -2 in this rational expression. Let's look at this example. The denominator cannot equal 0, so that means that the x cannot equal 9. Again, the denominator cannot equal 0, so we're going to work this out to figure out what number specifically x cannot equal. So in this case, we can actually factor out this polynomial, and we have x minus 7 and x minus 1. So we're going to have two different numbers that cannot equal 0. So x cannot equal 7 or 1 because it would cause the polynomial to equal 0. Let's look at this one. Now, if you look at 9, if we tried to factor this, our factors of 9 are 1 and 9 and 3 and 3. None of those add to make 3, so I would suggest we probably use the quadratic equation here. So whenever we plug everything in, we go ahead and solve out. Now remember this plus or minus, so we're still going to have two different answers that x cannot equal. And what they're going to be is either, if we solve this all out with our calculator and we do -3 plus 3 times the square root of 5, it either cannot equal 1.85, or if we do minus in the center, it cannot equal -4.5. Some rational expressions do not have any excluded values. There's nothing that could cause them to equal 0. For instance, let's look at this one. If we reduce down as much as possible, we end up with 20m squared over 3 times n. That's as simplified as it gets. If you'll notice, there was no plus or minus in that denominator. That might be a hint to you that there may not be an excluded value. So again, we just have a number at the bottom. That number can't equal 0, so there's nothing else you can do. But we can simplify this as much as possible. So we factor out the 3, and both of our 3's can cancel, and we're left with x plus 2. So whenever we're looking at rational expressions, we can factor out common factors, and then they can be canceled. But if they're only added or subtracted, they're just common terms, they cannot be canceled. So we need to think about the difference between factor and term. Remember, a factor involves multiplication. Terms involve addition and subtraction. So in this case, 2 and 2 cannot cancel out because they're not factors, they're only terms. Let's look at this one. Now, our excluded value is going to be plus 2 or minus 2, because positive 2 squared is 4, minus 4 is 0. Negative 2 squared is 4, minus 4 is 0. So we need to think about that when we're squaring things. It could be the positive or the negative of that number. And if we go ahead and factor all of this out, we can see that we're left with x plus 2 over x minus 2. Now, whenever we have x minus 3 or 3 minus x, they're opposites of each other. And we can actually change that around if we want to make x minus, if we have 3 minus x, we can make it equal x minus 3 by factoring -1 from the problem. So let's look at this one. Here on the denominator, we have 3 minus x. So if we factor out -1, first of all, our excluded value is 3. If we factor out -1, then we end up with positive x. We end up with -3 plus x, or we can switch it around and make it x minus 3. And still, x cannot equal 3. 3 is our excluded value for x. So whenever we look at this, whenever we factor that out, a nice thing to look for is if you have factors in the top, see if you can find the same factor in the bottom, or vice versa. If you have a factor in the bottom, see if you can find the same factor in the top, because then you can cancel them out. So now we're left with 4 times x plus 4 over -1. And you can actually simplify that to be -4 times x plus 4. And x, in this case, cannot equal 3, because we decided that at the very beginning. So that's the only number that we know x cannot equal for this experiment. Okay, go ahead and get started on your homework, please. Number 1 through 31, odd.